All right, everybody, we are in lesson 8.4. Similar triangles using the side, 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 and side angle side similarity. So again, S stands for sides and A stands for angles. And let me tell you, I had to cheat on this one. And what I mean is, I kind of looked ahead because I haven't taught this particular lesson in a long, long time. And I had someone ask me to do it. So when I got to that check on page 484 and there was nothing there to look at, I was like, yeah, my students are not going to get that, much less this person is asking me to do 8.4 because they don't understand or they have a question. Shoot, I would have gotten stuck on that check. So what I did is I made myself a drawing. So I'm going to use this drawing right here for that check on page 484. So yeah, I did a little schmoozing, with my computer program here to try and figure that one out. All right, so I got it. We're ready. So I'm going to shoot back and we're going to start off 8.4. So you guys on page 481, 8.4, and we are looking at two different triangles, obviously similar. Two things have to happen. Angles have to be congruent to each other, but sides must be proportional. That means they have to have the same scale factor, y'all. Now, two things we're going to talk about are the side, 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 which means all three sides of one figure, triangle, so to speak, and the sides of the other have to be the same scale factor. Now, what happens if we only know enough for two sides? Well, as long as the angle that's included between them is congruent to the other corresponding angle, from the other triangle, we're in business because we can use side angle side. I'll just get into it. So that right there is what I just explained to you. All right, visual people, my bad. So green side has to match up with green side. Orange has to match up with orange. And then blue with blue. So all three sides must be proportional. So let's say we don't have that third side. The angle between the orange and the green have to be congruent to each other. So angle S must be congruent to angle Y. That's side angle side. All right, let's do it. Example number 1 on page 481. All right, so I'm looking at a side, side, side because I don't have any angles. And remember, order matters here. So if you're wondering, how do you know what matches up? Well, remember, in my previous lesson, JL are my first two letters. They're going to go with QM because they're my first two letters. LK, my second and third, will match up with QP, my second and third. And JK, which is my first and third, will match up to QP because that's my first and third. All right, well, here we go. Okay. So let's see. JL is a 12. Oh, Lord help me. All right, QM is a 9. And that simplifies to a 4/3. Okay, LK is a 4. No, what am I saying? 8. And MP is a 6. And that simplifies to a 4/3. I was trying to simplify before I can even get started. That's not good. I have people asking questions left and right. Okay. JK is a 16. QP is a 12. And that simplifies to a 4/3. All right, so yeah, they are congruent by the side, side, side. I have 2, 3 S's. 1, 2, 3 are all 4/3. Okay, here we go. Going to the next page. All right, we got to check. All right, well, obviously this looks like more like a side angle side because I've got 2 numbers for the smaller triangle, 2 numbers for the bigger triangle, but not the third side. What I do have are vertical angles, or what my students like to call, hey, isn't that reflecting? Yeah, they're reflecting angles. Technically, they're called vertical angles. But yeah, hey, as long as they realize they're equal to each other, as a teacher, I'm incredibly happy. Okay, so here we go. We need to see if they have the same scale factor because I already know that angle W on the left, triangle, and angle W on the right, triangle, are vertical angles. They're equal. All right, here we go. Okay, so I need to match up. I love it when I can't move it. And that 10 right there goes with the 20. So 10 over 20. And that simplifies to a 1/2. Sorry. Technicals. All right, 11. So going to go with that 22. And that simplifies to a 1/2. So they have the same scale factor, you guys. And of course, one more time, angle W is congruent to angle W. They're vertical angles. So are they similar? Heck yeah, they are. By side, angle, side. And remember, the angle has to be between them. All right, example number 2. Okay, this looks definitely interesting. So find QN and PO and justify your answer. Okay, so don't forget these weird looking triangle right there means these are parallel lines. QN parallel to PO. Now, if you're a visual person like myself, I need you to see there are 2 triangles here. MQN is one triangle, and MPO is the other triangle. So when I'm first teaching this, I will separate these 2 triangles so my students can see that the side MP is an 8, because they're like, Miss Eccles, girl, why don't you use the 3? 3 is not the side of a triangle. 3 goes from Q to P. It's an 8 because M all the way down to P is 5 plus 3 is 8. If you're wondering where that 8 comes from. And then the MQ is the corresponding side. Again, if you are like sitting there going, Carl, what you talking about? Look at the order of the letters. MP is the second and third letter. It has to match up with QM, the second and third letter. That's where that 5 comes in. All right, so if you're sitting there lost as a goose, look at the order of the letters. That matters as well. MO is the first and third letter. It's going to match up with N and M, the first and third letter. So I know you guys don't like fractions and whatnot, but you have to add 6 and the 3 and 3/5 to get 9 and 3/5. So if you're sitting there going, where did they get the 9 and 3/5? MO is the side of a triangle, y'all, not NO. Okay, so with that being said, we need to set up a proportion to find x and then plug and chug. All right, so here is what they do. They do it kind of for us. So MP, the left side of that big triangle is 8. It's going to match up to MQ, which is the left side of the small triangle, 5. PO, that is my base, x plus 2 1/4, is going to match up to QN, and that's the base of the small triangle x. Cross multiply. 8 times x is 8x. Oh, okay, they went ahead and did the distributive property. 5 times x is 5x. 5 times 2 1/4 is 11 1/4. Subtract 5x to the other side to get 3x, because 8 minus 5 is 3. 11 1/4 divided by 3 is going to be, drum roll please, 15 over 4. How do they want it? They want it as a mixed number. So 3 3/4. 3 3/4. Now, since x is 3 3/4, and that is what side QN is, that means QN is 3 3/4. Oh, I forgot they wanted, they wanted perimeter? Is that what they wanted? No, they wanted QN, which I just found. Oh, they wanted me to find PO. I got to do a little plugging and chugging. All right, so they're going to plug that 3 3/4 right there, add it to the 2 1/4 to find the distance of P to O, and they get a 6. Okay, done with that. All right, we're on to the check at the bottom of the page. 482. All right, we got to find WR and RT, and I got to find X before I do any of that. All right, which means I got to set up a proportion. Okay, so let's see. WR is going to be matched up with TR. So X plus 6 over 2X plus 6. And then you can either go with the 8 and the 10, or you can go with the 4 and the 5. You're going to get the same answer regardless. I like smaller numbers, so I'm going to go with 4 and 5. So X plus 6 over 2X plus 6 equals 4 over 5. X plus 6 over 2X plus 6 equals 4 over 5. We're going to cross multiply that. Okay, so we're going to multiply 5 times the X plus 6. And we're going to multiply 4 times the 2X plus 6. Distributive property, 5X plus 30 equals 8X plus 24. Okay, let's see, subtract 5X to the other side. So 8X minus 5X is 3X. Subtract 24 to the other side, so 30 minus 24 is a 6. And divide by 3. So 6 divided by 3 is 2. All right, so every X is going to be a 2, and that's what I'm plugging and chugging. All right, so WR. 2 plus 6 is 8. Really? Okay, fine. 8. I don't know why they got to make things complicated. And 2 times 2 is 4. 4 plus 6 is 10. All right, guys, we got an 8 for WR. We got a 10 for RT. And we are done with example number 2. Moving on. All right, example number 3. I believe they did this one for us. Yes, they did this one for us. I know that because I looked ahead when I saw that check on that last page. I went, what? They give me anything to look at. So, yeah, they did this one for us. Oh, they don't on this in the book. I just noticed in the book they give you everything kind of drawn out for you, which is super nice. And here they don't. Well, on these people, come on, you guys, get it together. Y'all supposed to be smarter than me. Y'all got all kinds of letters behind your name that I don't have, and y'all can't make a model look correct. Bad people. Shoot, what am I saying? I went beyond and beyond right here, and y'all can't do the same. All right, let's do it. I'm on the check on the next page, page 484. All right, it says Justin is playing tennis. When serving, he stands 12 feet away from the net, which is 3 feet tall. All right, let me stop you right there. Okay, this is my net. This is the complete tennis court. Okay, you got a guy over here behind the line. You got a guy over here behind the line. So one person is 12 feet this way. Dude is standing right here, 12 feet from the net. So 12 to 24 is 12 feet. Again, there's my 12. So dude's standing over here somewhere. So don't you love my drawing? All right, let's give him some hair. Dude needs some hair. Okay, so this is the net that is 3 feet. And dude is standing 12 feet from the net. Okay, back to it. The ball is served from the height of 7.5 feet. So he throws the ball up, smacks it right there, 7.5 feet. Whoop, whoop. Whoop, whoop. Okay. All right, what we got here? Justin thinks the ball travels 21.4 feet before it hits the ground 8 feet from the net on the opposite side. So here's my 8 feet from the net on the opposite side. And the dude thinks that he smacks it 21.4 feet. 21.4 feet. Wow. Wow. Okay. So I got everything set up here. What in the world I gotta find? I forgot already. How far does the ball travel before it reaches the net? Round your answer to the nearest tenth. All right, so if you're wondering what they're asking, they want to know what CE is. What's the distance from when he smacks it to the net? We got to figure that out. Sure do. Alrighty, no problem. And then we'll ask what kind of assumptions we got to have, blah, blah, blah. Okay, so look, here's the deal. I got 2 triangles. I've got this small triangle, and I know 2 of its sides. I know the 8, I know the 3, so I can do the Pythagorean theorem to get this side. A squared plus B squared equals C squared. That would make my whole life a lot easier. I wouldn't have to do a proportion or cross multiply. But I also have a big triangle. And this big old triangle right here. Big old triangle. All right, so I can also set up a proportion, cross multiply, and solve. So I can go 8, which is the bottom of the small triangle, over 20, because that's the bottom of the big triangle. Excuse me. Hypotenuse x over 21.4. Hypotenuse of the big. Cross, multiply, solve. Or I can just do Pythagorean theorem to get this side. And then 21 minus 4 minus, that would be that right there. So, yeah. I mean, why would I not do shortcut? If you can remember the Pythagorean theorem, you don't even need to do a proportion or cross multiply and solve. So a squared plus b squared. Well, that's a horrible looking plus. Looks like a perpendicular sign. Well, I'm just making it worse. Equals c squared. 8 squared plus 3 squared equals c squared. Grab my handy dandy little calculator. Well, 8 squared is 64 plus 3 squared is 9. That's going to give you 73. And then the opposite of squaring is to square root that. So what we are finding is the distance of this hypotenuse of this small triangle. All right, so it looks like it's about 8.544. And a bunch of other numbers behind that. Boop, 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 boop. So let's keep going. All right, my lovely, we're going to take 21.4. We're going to subtract that 8.544 stuff. And that's going to give us our final answer over here. So 21.4 minus that, 12.855999625. So just subtract these two. Looks like we're going to get, what do we got to round to? Round to the nearest tenth. All right, we're rounding to the nearest tenth. So 12.8, 12.9, 12.9. 12.9 feet. There you go, my lovely people. You just found this right there is about 12.9 feet. Okay, so some of these problems, you don't even really need to do a proportion. You just got to know what you're looking at. So if you're a visual person like myself, sometimes having yourself a figure to draw kind of makes your life a whole lot easier. All right, you guys, so I am done. The practice problems are on you. Have a great day. You got any questions? Ask me. That's what I'm here for. You have a good one. Bye.